I'm Anil Kumar. Welcome to my series on inverse trigonometric functions. I'm going to discuss the very important properties of inverse trigonometric functions in this particular video. In fact, we are going to prove them all. Sine inverse x plus cos inverse x equals to pi by 2 if x is between -1 and +1. Second property is that tan inverse x plus cotangent inverse x is pi by 2 for all real numbers. And last, secant inverse x plus cosecant inverse x equals to pi by 2 when x is less than -1 and greater than equal to +1. Now, how do we get these properties? Well, we'll use two particular things. One is co-function identities. Let me just show you with the help of a right triangle. So let us say that we have a triangle here where one of the angles is x. Since this is pi by 2, the other angle here will be pi by 2 minus x, correct? So looking into this problem, you can always say that what is cos x equals to? Cos x is sine pi by 2 minus x. We could write the other way also, right? We could write sine x as equal to cos of pi by 2 minus x, correct? Since cos is adjacent over hypotenuse, sine is opposite over hypotenuse. But if I see from the other side, which is pi by 2, the adjacent side for x becomes opposite to pi by 2 minus x, right? So basically these are co-function identities. So that is one thing. Well, we could have written same thing for tan and cotangent also. So we could write cot of x is equal to tan of pi by 2 minus x. The other way also, and we can also write secant x is equal to cosecant pi by 2 minus x, correct? It's just seeing the triangle from the other side, you get to all the co-function identities, right? So that is one part which we should be very clear of. And since I'm going to use it in the derivation of all the three properties, so I thought let me discuss it first. The second point here is that we'll be working with, let's say if we are working with sine inverse, in that case, we know sine inverse is one-to-one function provided we work in the domain from minus pi by 2 to plus pi by 2, correct? So when we start with sine x, we have to see that x should be between minus and plus pi by 2. Now, when we have to switch to cosine, this particular thing changes to 0 to pi, right? Now, here also you see, we're talking about pi by 2 minus x. So, x is between all this, but what is pi by 2 minus x equal to? Rather, what should be the domain for pi by 2 minus x? That is very interesting. So, if I multiply by a negative number, this becomes positive pi by 2, sign changes, minus x greater than equal to minus pi by 2, correct? Or I could rewrite this as minus pi by 2. It's always better to write lower side on the left, minus x less than equal to pi by 2, correct? So we get this form. Now here, if I add pi by 2, then what happens, right? So if I add pi by 2, see, pi by 2 minus pi by 2 less than equal to pi by 2 minus x less than equal to pi by 2 plus pi by 2. So we added pi by 2 to all. So that results into 0. And we get the domain for pi by 2 minus x. Do you see that? And this is pi. So what is important to note is that when we talk about x between minus pi by 2 to pi by 2, in that case, we are saying that pi by 2 minus x is between 0 to pi. Do you understand? That is for pi by 2 minus x. Is that clear? So I want to make these two things absolutely clear when we begin with. So as you can see here, we'll prove sine inverse x plus cos inverse x equals to pi by 2. But we have to work with the argument, which is either pi by 2 or pi by 2 minus x. If we're talking about x, then x is between minus pi by 2 and plus pi by 2. And when we talk about pi by 2 minus x, for all inverse trigonometric functions, it is between 0 and pi. So I hope that point is absolutely clear. Now, let's begin to prove this one by one. So now I'll take up the first one, which is sine inverse x plus cos inverse x equal to pi by 2, when of course x is between minus 1 and plus 1, both included. Let us prove these identities one by one. We need to prove that sine inverse x plus cos inverse x is pi by 2 for all values, possible values for sine and cosine. So what we learned just now, that is very important to remember. That is, in co-function identity, we can always write that sine theta is equals to cos of pi by 2 minus theta. And when we say that theta is between minus pi by 2 to plus pi by 2, in that case, pi by 2 minus theta is between what? Is between 0 and pi, correct? So these two things we just showed you, you have to remember, correct? Now let's begin. So sine inverse x. So let us say that let sine inverse x be equal to theta. That really means that x is equal to sine theta. Perfect. Now what is sine theta? Sine theta is cos pi by 2 minus theta. So now this is what it is. So x is equals to cos pi by 2 minus theta. So I could now write this as cos inverse x is equal to pi by 2 minus theta. Is that clear? Now cos inverse, as you know, is defined only in the interval 0 to pi, correct? As shown earlier, correct? And this theta is defined between minus pi by 2 to pi by 2, sine inverse. Does make sense to you? So it is a very important part of proof. So I'm not doing it again and again since I've already done it for all, right? That's the whole idea. So what you get from here is that sine inverse x is theta 1 and cos inverse x is pi by 2 minus theta. So what is this combination equal to? Let's substitute. We want to know what is sine inverse x plus cos inverse x. So let us substitute. Sine inverse x is theta plus cos inverse is pi by 2 minus theta. And when you combine, you just get pi by 2. Doesn't make sense to you, right? So that is how we prove this identity. So I hope these steps are absolutely clear. So we have shown this, right? So we'll follow very similar steps to show the other two. So let's prove tan inverse x plus cotangent inverse x equal to pi by 2 for x belongs to real numbers. Now let tan inverse x be equal to theta. Now tan inverse x is defined when theta is between minus pi by 2 to pi by 2, correct? Now, from here we can write x is equals to tan theta. That could be written as cot of pi by 2 minus theta. Now this is co-function identity, you know, right? Now we can write what is cot inverse x equal to. Cot inverse x is equal to pi by 2 minus theta only if pi by 2 minus theta is within what limit? 0 to pi, right? And we know that. We have already shown this, correct? We showed that this is true. Pi by 2 minus theta is within 0 to pi. And that is where cotangent inverse is defined. Perfect? So that was important to work with. Now, since we know from here, we can say 1, we said tan inverse x is theta. 2, we have shown that cot inverse x is pi by 2 minus theta. So if we substitute these values in our original equation, which is tan inverse x plus cot inverse x, what do we get? For tan inverse x, it is theta. And for cot inverse x, it is pi by 2 minus theta. So when you combine, you do get pi by 2. Is that okay? So that is how you prove the identity. So we have again shown how to prove this particular identity. Correct? Now let's move on and do the same for secant inverse and cosecant inverse x. We'll follow exactly the same method. So let secant inverse x be equal to theta. Now here it is important to note that theta actually belongs to 0 to pi but is not equal to pi by 2, right? It is not defined. Secant theta is not defined for pi by 2. That really means that theta is between 0 to pi where theta is not equal to pi by 2. Correct? Now, if I do minus, then I get 0 is greater than equal to. When you multiply by a negative number, the sign changes, right? Minus theta is greater than equal to minus pi. Now, on the other side, it is better to always write lower things on the left, so I prefer to write it like this. Correct? We are interested in pi by 2 minus theta. So let me add pi by 2 to all these. So if I do that, we get pi by 2 minus pi less than equal to pi by 2 minus theta less than equal to pi by 2. Now, as far as pi by 2 minus theta is concerned, since we know that theta is not equal to pi by 2, we know that pi by 2 minus theta is not equal to 0, right? Bringing it on the other side, we know pi by 2 minus theta is not equal to 0. So that is kind of important to understand. Now, pi by 2 minus pi gives us minus pi by 2. So we get pi by 2 minus theta less than equal to pi by 2, where pi by 2 minus theta is not equal to 0. So this is very important to understand. The restrictions on theta, correct? Now let's continue. So secant inverse x equals to theta, that means x is equals to secant theta. And secant theta could be written as cosecant pi by 2 minus theta. So that means cosecant inverse x equals to pi by 2 minus theta. And once we know that, we could always substitute, right? So getting back to our equation, which is secant inverse x plus cosecant inverse x, we'll substitute these values. So what we get here, secant is theta plus pi by 2 minus theta, and that gives us pi by 2. Does it make sense to you, right? So that is how you prove this identity. So I hope the steps are absolutely clear. We are going to use these identities to solve or evaluate many expressions or equations soon. So I hope that helps. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.